Dear students, today we will discuss about stress and strain. So in last class we have discussed an introduction of elasticity. So finally I have taken one example, that is a spring model example. It means one of the spring is attached to the wall and then on a table placed on a table, and a force is given to the one another end of the that spring. So if you given a force, then what happen, the spring is stretches, it means it displaces some of the displacement. So here if the that spring is stretches, it means the force is applied on the that spring. If the force is applied on that spring, how much it stretches or changes its configuration, that much of the internal force is restoring on that area. So here that will gives the stress on the spring. So what is the stress here? Stress is restoring force for unit area or a cross sectional area. Another example, this is the box. So on this area I am applying the force. On this area I am applying the force. So applied on area is gives the stress. Stress equals to applied force per unit area is also called as a stress. So what is the SI unit here? We can take a formula for the stress, that is force per unit area. So force is a Newton and area is a meter square. So therefore Newton per meter square is the SI unit of that stress. And now what is the dimensional formula? Dimensional formula I have written here. So the dimensional formula is, see here, the force is mass into acceleration divided by length, that is L square. So now here mass is written as m1 and acceleration is written as L raised to 1 t raised to minus 2. So therefore here the meter square is L square. So therefore the dimensional formula of the stress is m1 L raised to minus 1 t raised to minus 2. This is the dimensional formula of the that stress. What is the stress? Stress is the internal restoring force. It means if you are stretching the rubber, the initial rubber has the length L. Example I am taking here. If you applied a force, then the length of the that rubber it changes. Again, if you remove that force, that body or a rubber is regains its original position, that is L. So the responsible to change their length, is the restoring force inside the dead body. It means the body is restores the some force inside the body, that is equals to the applied force. The restoring force is there, that is equals to the applied force. So nothing but here the restoring force unit area for unit area or a applied force per unit area. So here the stress has three types. It means we divided into the three types. How you dividing? We are dividing on the basis of the applied force here. So how you are applying the force? On what basis you are applying the force? When an external force is applied on a body, there may be deformation. It means there may be changes in the dead body. It may be changes in the length, or it may be changes in the volume, or it may be changes in the dead displacement or relative displacement. So first one will call, that is longitudinal stress. One is a longitudinal stress, and second one is volume stress, and third one is bulk stress, or it is called as volume stress. Volume stress. So now we'll see one by one here. What is the longitudinal stress? Longitudinal stress. So here I will take one example. This is the length of the rod. This is the length of the rod, and then this rod is tied with the wall. Ceiling. It means the length of the rod is tied with the ceiling, and now another one of the end is free end. So what I am doing, I am applying a force here. I am applying a force here. It means lower part of the that rod. So if you applied in this situation, or in this longitudinal direction, so that applied force in the longitudinal direction is called as a longitudinal stress. Is called as a longitudinal stress. See here, when an external force is applied on a body, there may be deformation its length or size or shape. Here it is not size and shape. It is only changes in the length. Which force is responsible to change their length after applying a force? So that force is nothing but the longitudinal stress or a longitudinal force. It means here also longitudinal stress is equals to force per unit area only. Force per unit area. So what is the SI unit? Same as for that stress. So next here, in longitudinal stress we will get another two types. One is a tensile stress, another one is a compressive stress. So what is tensile stress here? Tensile stress. See here, when an external force, we are applying a external force to that body. Any body you can take. So here, when an external force is applied on a body, the body changes its length as in increasing order. If you applied a force to the body increases its length, then it is called as, that force is called as a tensile stress. If the body decreases its length after applying a external force to the dead body, that force is called as compressive stress. It means we are applying a force in opposite direction, and that maybe changes its length after applying a force as in a decreasing order. See here, this is the original length of the dead body. After applying a force, the body maybe decreases its length. Delta L is decreases. So that is called as compressive stress. Now second one, that is volume stress or bulk stress. What is the bulk? Bulk, it means all together, number of the units or a number of the forces acting on the body. Let us take one example. This is the box. If I applied the force on this piece, it means that is only on area. That force is only on area. That is gives the any one of the stress as tensile or a compressive stress here. So for this bulk stress, we should apply the force in all possible directions. That is called as, if it is applied like this, then the force is called as bulk stress or volume stress. So it means the body is having the volume here. This body is having the volume. So we are applying in all direction to the data body. That is nothing but the force is applied on that volume. That is gives the bulk stress. So here another one example will take, that is I will take here, this is the one of the jar, and then that jar is consisting of the hot water. So we'll take one balloon, balloon, and then we'll insert into that jar. So that balloon is having the phi volume. So after applying the balloon into that jar, then the balloon is decreases its volume. So why it is decreases? Because here the water pressure or a water gives the stress on that balloon. It is responsible to change their volume. So that force is called as a volume stress. So here when an external deforming force is applied on a body, changes its size. So here the size of the balloon is this much, and then next after applying the force, the volume of the balloon is changes size. Then the stress set up inside the body is called as set up inside the body. It means so that force is restores the inside the body, and after removing of that body out of this water, then the body again regains its original position. So that is called as a volume stress. And then next third one, that is shearing stress or shearing strain. Shearing stress, or it is called as tangential stress. So what is a shearing stress or a tangential stress? See here, let us take one example, that is this is a box which is placed on the table, and then the lower face of that box is fixed to that table, and upper part is a free part. So now we'll apply a force to that upper part as a tangentially to that body. The body will changes its shape after applying a force. So which force is responsible to change their shape? After applying a force, then it is called as shearing stress or tangential stress. It means the applied force is as tangentially. So that's why it is called as a tangential stress. See here, if you applied here, then it does not change its shape. Okay, for example, you have to take a thicker of the book and then applied a one side of the force to that book, and then that pages will displaces in the making an angle theta. So here the angle will get. So when an external force is applied on a body, the body changes its shape, then its stress is set up inside that body and called as a shearing stress or tangential stress. So now we'll go to the next concept, that is strain. When an external force is applied on a body, the body changes its shape, size and the length. That is gives the responsible of that force. That is due to the responsible of that force. So here that change is in the body, that is gives the strain. After applying that force, that body configurations is changes. That configuration changes is called as a strain. For example, what you are going to do, we are taking one example, that is a rod, and then we are applying a force in this direction here, and the body will change its so applied force is called as stress, and then the body will increase its length is gives the strain. Length will gives the strain. So here the stress and strain are directly proportional. So how much you are applying the force, that much only it is changing its configurations. So now here, what is the strain? Strain, when an external force is applied on a body, there may be deformation in its length, size, shape. The amount of deformation produced in the body can measure the terms as quantity called as strain. So another one definition, that is the strain of a deformed body, deformed means change in the body, is defined as the ratio of change in any dimensions. It means strain is equals to the ratio of change in any dimensions to the original dimensions. It means, see here, this is one of the length of the rod is there, that is L I will take. So after applying the force to that rod, then what happens? The rod length is changes. That rod length is changes. So here the strain we can define. So that is change in the length is, that is delta L, and then original length is L. So like this we will define that strain. So here also we will get three types of the strain. So one is called as a longitudinal strain. One is a longitudinal strain, and second one is volume strain or bulk strain, volume strain, and third one is shearing strain. So we'll see one by one here. First one is longitudinal strain. So what is a longitudinal? What we are going to do here, we are applying a force. On which direction we are applying, or we will apply a force as a longitudinally, So if you apply the force as a longitudinally, it means a longitudinal stress is applied on a body. Then after applying a force, the body may be changes its length. So the original length is a L, and then change in the length, that is delta L. For example, I will take here, this is the L, and then change in the length is delta L. So we can define the longitudinal strain, that is the ratio of change in length to the original length, that is equals to the L, delta L divided by L. So here what is the SI unit? Delta L is in meter, and then this L is in meter. So get cancelled. Then what remains? The strain doesn't have any units. So it is a unitless quantity. The strain is a unitless quantity. We'll call it is a strain is unitless quantity. So now next one is second, volume strain. Similarly here, what we are going to do, we are applying a external force in all possible direction. So that is called as bulk stress or volume stress. So now here, before applying the external force, the body has a volume phi. So after applying a force, that body decreases the size of the, here after applying, the body changes its volume. So that change in the volume is called as a strain. So volume strain is defined as the ratio of change in volume to the original volume. So this is an example we'll take for the volume strain. So next, third one is, that is a shearing strain. So what is the shearing here? Shearing means the relative displacement in that body after applying the external force. relative displacement of the body, it means, we will take one example. The box is placed on the table and the lower part is fixed, upper part is free, and then the tangential force is applied on that body. The body will changes its shape, and then some of the body will displaces. So relative displacement, and here L, X and L will take. L is the length of the dead body and X is the relative displacement. So therefore here, after applying a force, that body is displaces with an angle theta, So therefore here, the shearing strain is defined as the ratio of relative displacement, to the original length of the body, So therefore we will take, that is, angle is a tan theta, relative displacement is delta x we will take, or a x we will take, and the original length is L. So therefore the shearing strain we can define a tan theta equals to delta x divided by L. Okay, now this is all about the stress and strain. So using this stress and strain concept, the Hooke performed one experiment to study the relation between the stress and strain. What he told, the Hooke's law, whatever the that experiment is there, for that experiment or a presentation, they gave the name for Hooke's law. So what is the Hooke's law here? For a small deformation, or it is an elastic limit, the stress is directly proportional to the strain. He told that in elastic limit, the stress is directly proportional to the strain. What is the elastic limit here? See here, one example I will take. So one of the rubber is there. This is a rubber I will take. So if you applied a force on that rubber, it means you are stretching so many times. So many times, it means one time you are applying a small amount of the force on that one, and then again you are removing that force, again it is what happened, regaining its original position. So next I am applying again another one of the force, it is small increase before force. So continuously what I am doing, I am applying a force as an increasing order, leaving the force, and then it is regaining its original position again and again. So finally what happened, one of the time that force is maximum force, which is responsible to break that rubber, What happened here, that rubber is also have some limit, to get its original position or regain its original position. So that is nothing but the elastic limit. What it is called as? It is the maximum value of the stress. Of the stress or a load per unit area. See here, this is one of the rod is there. Maximum stress applied on that area, up to which the material regain its original state. Up to that material regains its original state on removal of deforming force. When an applied force is a maximum, it is responsible to break their elasticity. So that is, up to that force is called as elastic limit. So here, in an elastic limit only, the stress is directly proportional to the strain, then the Hooke's law is obeys for that material. So here stress is directly proportional to the strain. is called as Hooke's law. Hooke's law. And stress equals to K into strain. So therefore K is a modulus of elasticity. Modulus of elasticity. So therefore K equals to stress divided by strain. Stress divided by strain. So this is about the Hooke's law. In the year of 1635 to 1705, the English physicist was performed this experiment. So that is using one of the metallic wire, and performed on this metallic wire, applying a force continuously, and so he see that behavior of the material, and finally they got as a stress is directly proportional to the strain term. So in the next class we'll see the behavior of the stress and strain curve.